So now we've talked about what data is. We've talked about the types of data. We've looked at the forms as well. What then is data analytics and who is a data analyst? Now, data analytics is simply a discipline that focuses on the gathering, the transformation, and analysis of data for the purpose of drawing conclusions and gaining reasonable insights that can aid in making data-driven decisions. Okay, who then is a data analyst? A data analyst is simply someone that does data analytics. Yes, so what does he do? He gathers data, he cleans them, he transforms the data, he visualizes the data, he analyzes and he visualizes the data so that he can gain information that can help him provide solution to a business problem. All right. So he needs some thinking skills. He needs some analytical skills, definitely. But he also needs some application skills. He needs to know how to use some certain tools. And that is the reason why you are here. You want to know how to make use of Excel. You want to know how to make use of Power BI. You want to know how to make use of SQL. You want to know how to make use of Python. For what reason? So that you can analyze data. So that if they give you data, you won't just be looking at the data and be wondering, where did you start from? Where did you go to? Isn't it? That is data analytics. That is who a data analyst is. Okay. So now you've been hearing data analysis, data science. Some of you came across data science. Some of you probably even entered into data science and decided, it seems data science is not for me. I'll go into data analysis. Isn't it? So what is the difference between data analysis and data science? How I like describing it for my students is this. Think of data science. Now, the definitions differ, okay, depending on the person giving it and depending on the context, okay? Some people will say, oh, data analytics is like a broad overview. Some people will say, oh, data science is like a broad overview, all right? But you have some type of analysis. And I'm going to talk about those type of analysis shortly. But where data analysis or data analytics stop is where data science kind of like takes it a step further. Because in data science, practically, they work mainly with programming, Python, R, or other languages. Okay, and what do they use them to do? You begin to see things like advanced analytics and machine learning. So when you're talking about predictive analytics, okay, prescriptive analytics, these are the data scientists' work. Okay, but you need to know that a data scientist is also first an analyst. Okay, a data scientist is also first an analyst. That is the reason why you see, oh, they'll say we do predictive analysis. They won't say we do predictive sciences or predictive science, isn't it? They will say we do predictive analysis. So they are also analysts. Okay, it is just their name. Oh, let's just give them this name to distinct, be able to differentiate them. Oh, that, oh, they take it a step further. They use machine learning and some other things to be able to, battle the data and gain meaningful insights from it. All right. Now we have some popular tools used in data analysis. Okay. And these are popular tools used worldwide. Okay. Popular tools used worldwide. All right. Microsoft Excel, Microsoft Power BI, SQL, Google Sheets, Tableau, R or Python, SAS, Jupyter Notebooks. Okay. But in this program, we're going to be focusing on Excel, Power BI, SQL, and Python. All right. Excel in the place of, or Google Sheets can also compare to Excel in some cases. All right. Tableau can compare to Power BI in some cases. Then we have Python or R, both are programming languages. Then we have SAS, and then we have Jupyter Notebook. We're going into some more interesting aspects. Let me see. Okay. We now want to see the types of analysis. Okay. When we're talking about analysis, all right, you need to know that most times data analysts are performing a particular kind of analysis without even knowing. Okay. Analysis. Okay. So I included this type of analysis in my slides for just one reason, so that at any point in time when you're analyzing data, okay, as a data analyst, it's just descriptive and diagnostics you'll be doing most times. All right. The entire thing is usually more of the data scientist work when you're having predictive and prescriptive as well. Okay. And then there are some methodologies that data scientists use under descriptive and diagnostic as well. Okay. So we'll see some methodologies there that are actually the data scientists work. All right. Rather than, oh, maybe the data analyst. All right. And we'll mention that very soon. But the reason why I added this is so that, let's say, for instance, you're analyzing data and someone just asks you, what kind of analysis are you doing currently? Do you get that? Okay, you don't usually get that question, definitely. And many people don't know. But I just noticed that if I just ask someone, what type of analysis are you doing at this stage? They won't know. Okay. Although we don't usually differentiate them like that. Okay. But I just like to mention it. So now, descriptive analysis. When we say descriptive, we're describing what does it look like? What? We want to know what happened. So this kind of analysis usually deal with the question what? W-H-A-T. What? So it's in this place that we analyze data. Most times, historical data. We want to know what has happened in the past. Okay. Now, descriptive analysis does not go deep enough to explain the causes of these outcomes, though. But what does? Diagnostic analysis. Okay. Diagnostic analysis. So while prescriptive analysis deals with the what, diagnostic analysis deals with the why. Why does something happen? All right. So after discovering patterns in the data, you want to know the reason why those patterns occur. All right. For example, after discovering an increase in the sales of a company for January, the data analyst will want to take a closer look to the data to find out what could have led to this increase. If I ask you, for instance, now that, okay, let's take a look at something. So if I say there is a trend in our data, so we're currently analyzing something, okay, and there is a trend in our data. We see that sales increased. We started the business in 2016. 2016 to 2017, it's increased. To 2018, it's increased again. To 2019, it's increased again. In 2020, we noticed a decline in sales. In 2021, it increased, it picked up a bit. In 2022, it picked up again. 2023, it picked up again. But then in 2024, we're noticing another decline. So what can you say? Oh, because now we know what happened. We know what happened. There was a decline in 2020, and we're noticing another one in 2024. But the truth is, if you don't analyze your data, okay, if you don't analyze your data, you won't see that trend. All right. So it is easy for you to, or for us to say that, oh, COVID, inflation. All right. But at times, the data scientist might step in and begin to apply some statistical methods, trying to see, okay, if it is not natural causes, what then could be the cause again? All right. But before you can get to that stage, you need to analyze your data to see that pattern. You see this diagram that I have here. You see this. Eh? Before you can get this, you need to analyze your data and build a visual on it. If you don't do that, you won't be able to make that conclusion. So for you to be able to analyze that data and build that visual is what we're going to be seeing. That, okay, you want to analyze, you want to get an understanding about this data and to build a vision that can easily communicate that insight is what we're going to be seeing majorly in Excel and Power BI. All right. Then we have predictive analysis. Here, the analyst. Okay, remember I said data scientists are also called analysts. All right. So here, the analyst wants to predict the future outcome. This is the data scientist work. Okay, based on the analysis done on the historical data. I worked on a food price project with an organization in the University of Lagos. I think that was earlier this year. And basically, what the project entailed was we had a team of data analysts, machine learning engineers, AI professionals, and they collected the data. So the data engineers and scientists, they scraped the data from various sources. All right. They brought the data together and I was recruited, and my role basically was to collect this data. They've done some cleaning, but I still had to clean and do some transformation on my own end, okay, to make the data suitable for my own analysis. So practically what my work just included was analyze this data and let us know what the price of goods are saying in the market from this time to this time. When I analyzed the data, they saw the trend. There was a particular trend that they saw. Oh, beautiful. Then what else are we going to do? Then the data scientists now took it up again. That, okay, based on this insight that we've gotten, can we predict what is going to happen in the next years for each of these food items? Okay, so we had data on a lot of food items. A bit, but it's still in progress. Okay, because some of these things are not just things that you just do in a day or 2 days, depending on how tasking it is. This particular one I'm talking about is very, very tasking. It might sound very easy and oh, it should be a walk in the park. I mean, but no, until you get into the work itself. Right. So the predictive analysis is usually the data scientist work. Oh, we want to use machine learning to predict. You train a machine learning model and it makes predictions for you. Okay, and then prescriptive analysis. Oh, how should we go about it? We want to meet it. We've predicted a 20% increase in sales. What do we do to meet that prediction? Do we just sit on our oars or do we stand up and change some certain things? Okay, let's consider different scenarios. Okay, if we go this route, how does it happen? If we go this route, what happens? If we go this route, what happens? Okay, so anybody you see that does all these kind of things are analysts. Okay, but analysis is different from analysis. All right. So I think all that is left now is for us to take a look at some industry-based use of data analytics. Then we'll take a look at the phases of data analytics. And then we'll now take a look at domain knowledge and use of Google.com. So let's see, industry-based use of data analytics, the health sector. One thing I tell people is, as a data analyst, yes, you might be able to work on different kinds of data, okay, but you need to find your niche. Okay, I think I'm already jumping. I'll speak about that in domain knowledge. Okay, but data analytics is very useful in various sectors. In various sectors. Okay. There was an article I read, and a particular what's it called now? Hackathon that was done regarding the healthcare system in Africa. Okay. And practically what that hackathon required was they gave us data and they wanted us to analyze and bring out insights from the data. Okay. And it was basically on the healthcare sector in Africa. So we were looking at things like child mortality rate. We're looking at things like, oh, what could cause it, the causes, malaria. Oh, and then we saw that malaria was not actually the main cause of child mortality. Okay, but at times, if you don't analyze data, you just go with the assumptions that people in the world are basically assume that okay, this is what causes this or this is what causes that. All right. We saw that there was a particular, I've forgotten the disease, and it happens because of lack of vaccine. We saw that malaria actually affects, or it actually causes high rates. That's a high rate of child mortality. Okay. But we saw that it was not the highest. If they ask, oh, what's actually affecting people in Africa or child in Africa now, many people will say malaria, malaria, malaria. But we saw that the highest, about two, were the ones that had to do with, I've forgotten this particular disease now. The hackathon happened, I think, last year or 2 years ago. Yeah, I've forgotten that particular disease, but it is preventable by vaccine. So we saw that children, there were a lot of children dying as a result of that disease. But why are they dying as a result of that disease? Why is the mortality rate that high? It's as a result of vaccines not being available to a large proportion of Africans. Do you see this now? Okay, so if those data or if the data that was collected were not properly analyzed, we wouldn't have gotten those insights. All right, so the healthcare sector makes use of data analytics so much. Apple wristwatch now can track how you sleep, your sleeping pattern. It can tell you if you are stressed. It can tell you if you need to do some exercises and things like that. It will track the amount of hours you sleep, where you woke, and so many more. And all it's basically doing is it's analyzing your sleeping pattern. Okay, this same analytics can help you to identify patients at a high risk of disease. When you see that there's a pattern, people that are overweight tend to gain diabetes. People that are obese tend to gain diabetes. People that are obese and don't exercise tend to gain diabetes. And you see as a pattern. When you see somebody that is obese and doesn't exercise and they come to you, your first instinct, the first thing that will come to your mind is if you're not careful, you might gain or you might get diabetes. What you have simply done there is you have analyzed data and you made conclusion. Okay, so in the healthcare sector or in the health sector, data analytics is very important.
Drop your questions in the comment section. Thank you.